All right, so you're trying to wrap your head around C++ enums. I get it. Sometimes a full lecture can be a bit much.
Yeah, totally.
Especially on a topic that seems kind of simple at first glance.
Yeah.
You sent us this YouTube transcript from Professor Jerry C. Tsoi,
Okay.
and we figured let's do a deep dive and help you extract just the core ideas.
Right.
What are C++ enums all about? How do they actually work?
Yeah,
And why should you care? Why are they important?
exactly. It's almost like we're doing like the Cliff's Notes version of a lecture,
Yeah.
but maybe a little more depth than Cliff's Notes.
Yeah.
So Professor Stoy, he gives a really thorough overview, but we want to zero in on what's really going to make a difference for you as a programmer.
Okay, so Professor Soy starts off, he's talking about how enums let us create our own simple data types. And like we're used to the basic ones in C++, like, int, char, float.
Right.
What does it actually mean to go and define our own simple data type?
It's a great question. Because on the surface, it might seem like, okay, why would I bother? I've got these built-in types, they work just fine. But it's all about control and clarity.
Yeah.
Instead of having these general-purpose containers for data, like int that could be anything,
Right.
you're saying, I'm creating a type that is specifically designed to hold only these named values.
Mm-hmm.
So it's like making your code speak a more precise language.
So it's like a category with specific, like, preset labels almost.
Exactly. It's like you're defining a very particular vocabulary for this aspect of your program.
Okay, I like that.
Instead of using numbers that could mean anything, you've got these descriptive names that immediately tell you what's going on.
So how do we actually go about setting one of these up? What's the syntax look like?
So the general form, it's pretty straightforward. Professor Tsoi lays it out as enum type name, value 1, value 2, go rel e.
Okay.
And the magic here is that type name, that becomes your new data type. Like
Mhm.
you can use it just like you would use int or char.
Yeah.
And those value 1, value 2, and so on, those are the specific allowed values for this new type. They're called enumerators.
Okay.
And they're not variables themselves, they're identifiers.
Okay, got it. So it's like setting the valid options for a drop-down menu or something.
That's a great analogy. It's like saying, here are the only choices you have for this particular thing.
Okay, so, all right. So he mentioned something about the order that we list these values in matters. Can you break that down?
Absolutely, that's key. So when you define your enumerators within those curly braces, C++ automatically assigns them an underlying integer value, starting from 0 for the first one, 1 for the second, and so on.
Oh.
So he uses the example of blue and red. Let's say you define enum colors, blue, red. What the compiler actually sees behind the scenes is blue is 0 and red is 1.
Gotcha. So even though we're working with these names, there's a numerical kind of backbone to it.
Exactly. And this is where the idea of type safety comes in, which is one of the huge benefits of enums.
Okay, type safety. How does that tie into enums?
Think about it. If you didn't have an enum, you might represent colors using just plain integers, right? 0 for blue, 1 for red. But what happens if somewhere in your code, a variable that's supposed to hold a color accidentally gets assigned, like the value 5?
Oh.
With an enum, the compiler would be like, whoa, hold on, 5. That's not a valid color according to your definition. And it would flag that as an error.
Right.
So you're preventing a whole category of potential bugs right there.
Okay. It's like, it's not just making the code nice and readable. It's like, it's actually preventing us from doing something dumb.
Exactly. Enums help you build these guardrails into your code.
Okay. All right. So Professor Soy was pretty explicit about some things that we can't do with enums.
Right.
We can't just do normal math on them, right?
Yeah, no, straight up arithmetic. It doesn't really make sense conceptually either. Like, what would it mean to add blue and red?
Right. Yeah. What color would that even be?
Yeah, exactly. The result wouldn't naturally fit within that colors category that you've so carefully defined.
Okay. And so no like incrementing and decrementing either. So if I have like my colors variable, I can't just do my color plus plus to cycle through them.
Nope, they're not just numerical variables that you can step up or down. They represent distinct states, not a continuous range.
Okay. But he does mention this cast operator as a way to kind of move through the sequence, even if we can't just directly increment.
Right. So it's not about like adding 1 directly to the enum. It's about saying, hey, compiler, treat this integer as if it were a member of this enum type. So if you have colors, my color equaled blue, you can't do my color plus plus en, but you could use something like my color static cast colors, my color plus 1, and that's going to take you from blue, which is 0, to red, which is 1.
Okay. So we're kind of like using that underlying integer representation, but we have to be explicit about it.
Exactly. It's a deliberate action. And importantly, this is what's called a staticast, which happens at compile time. It's not some like wishy-washy runtime conversion. The compiler's checking if it makes sense according to your enum definition.
Okay, got it. That makes sense. Now, what about comparisons? He said we can use things like greater than or less than.
Right.
How does that work if these aren't like literally numbers in the way that we usually think about them?
Because remember, they do have those underlying integer values
Yeah.
based on the order you define them.
Right.
So if we stick with enum colors,
Mm.
blue, red,
Right.
PO red, having the value of 1 would be considered greater than blue, which has a value of 0. You're essentially comparing those implicit integers.
So the order that we list them in matters not just for readability, but for how they actually behave in the code?
Absolutely. That order defines their relative values. Okay, now let's talk about getting these enum values in and out of our programs, input and output. And Professor Soy uses this phrase done indirectly. What does that mean? What does it mean for us as programmers? C++ input output, like the sin and count stuff. It's designed to work with those fundamental types, integers, characters, and so on. It doesn't inherently know what to do with your custom enums.
So I can't like have the user just type blue and have that magically become my colors variable.
Not directly, no. Similarly, if you try to just print an enumerator, what's going to show up on your screen?
I'm guessing just that underlying number, not the nice name. So printing blue would just show 0.
Exactly. That's why it's indirect. You have to write code to bridge the gap between those human-friendly names like blue or red and their internal integer values.
Okay, so enums aren't like magically inputable or printable by their names. We got to do a little bit of work to make that happen.
Right. You provide that translation layer. It's like writing a little dictionary for your program to understand your enums vocabulary.
Got it. Okay, so now he also talks about using enums with functions, which sounds pretty neat.
Right. This is where they really start to shine.
Okay.
You know, just like you can write a function that takes an integer as input or returns a Boolean, you can do the same with your custom enums. A function can take an enum as a parameter, either by value or by reference, and it can return a value that is of an enum type. It really makes your functions more expressive.
Okay, all right. I'm starting to see the power here. So now let's get to that Harry Potter example.
Oh yeah, the spells.
Professor Soy used to tie all of this together.
Perfect example.
Yeah, it should make it a lot more concrete.
Right, so he defines enum spells, Expelliarmus, Lumos, Alohomora. You see how much more readable that is. Instead of just using like 0, 1, 2 for different spells, you've got these meaningful names.
Right, yeah.
And of course, Expelliarmus gets that default value of 0, Lumos is 1, Alohomora is 2.
Right. Then he makes a variable called Harry Chant, which is of this spell's type. Just like, you know, you might say, int my age. Now it's like spells Harry Chant.
Exactly. And then he introduces these two functions, getChant and displayChant. Let's start with getChant. What do you think it does?
Okay, so getChant, it takes a single character as input, like E, or eel, and it's smart enough to handle both lowercase and uppercase. Then inside, it's got a switch statement that figures out which spell's enum value to return based on what that character was. So if you type in like E, it'll return Expelliarmus.
Exactly. That's how you input an enum value, by mapping some other input to one of your defined options.
Okay.
And importantly, the return type of that getChant function is spells. So you're guaranteed to get a valid spell back.
Makes sense. Okay, so what about displayChant? What's that one all about?
DisplayChant takes a spell's enum value as its input, and it also uses a switch. But this time, instead of returning something, it prints the actual human-readable name of the spell to the console.
So like if I give it Expelliarmus, it'll actually print out the word Expelliarmus.
Yep, that's the indirect output in action. You're not printing the enum value directly. You're using it to decide what to show to the user.
Right, because if we just tried to print that enum value, we'd just get 0, 1, or 2.
Exactly. So this displayChant function is acting like the translator. It's turning that internal representation into something meaningful for us humans.
Okay. And then he shows us how if the user types in E, getChant will return Expelliarmus, and then displayChant uses that to print Expelliarmus.
Right. It all fits together nicely.
Yeah.
But then he goes back to that cast operator idea.
Right.
He's got this line, Harry Chant static cast spells, Harry Chant +1. What's going on there?
Okay, so if the user typed E before, Harry Chant would be set to Expelliarmus, which is 0, right?
Right.
So he's adding 1 to that, which gives us 1, and then using that static cast to say, treat this one as a spell's enum value. And since the second spell on our list is Lumos, that's what Harry Chant gets updated to.
Precisely. It's like a way to move through the spells in order, even though you can't directly increment the enum.
And that's why if he runs it again and the user types E, the output is now Lumos instead of Expelliarmus.
Exactly. A clever little trick.
Yeah.
A practical way to work with those enum values.
Okay, so we've covered what C++ enums are, how we define them, those limitations on arithmetic and I/O, how they work in functions, and we even walked through this cool Harry Potter spells example.
Right, just like a mini crash course.
Yeah.
So to sum it up, C++ enums give you this power to create your own simple data types, defined by specific values. Those values have a defined order, and you can use those enums in your functions to make your code more readable and more type-safe.
And all of this without having to watch the entire YouTube lecture.
Exactly. We've distilled it down to the essentials.
Awesome.
So the takeaway for you, the listener, think about how being able to create these custom types, even something as simple as an enum, can really impact the way you write software. It's about making your code more expressive, more reliable, and less prone to errors. You're no longer just throwing around raw numbers or strings. You're working with meaningful, well-defined concepts.
Right, making the computer understand our intentions a little better.
Exactly. What other real-world ideas, what other concepts could you represent using enums? That's the challenge I leave you with.
Ooh, that's a good one. All right, well, until next time, happy coding.
Keep exploring.